Welcome to qnawire.
Well, let us draw the figure, right? This is CD, and this is C, and this is D, right? And here, electric current is in this direction, in the direction of arrow, right? And then here, this one is point A, and this one is point B, and this length is height H. This length is height H, and current is traveling from A to B here, right? So weight is acting vertically downward, that is equal to mg, and then force, and there is a force opposite to this mg, right? Okay, now consider this figure where the wire CD is free to slide up vertically. Both CD and AB carry a current I. We know that for two parallel conductors carrying current in the same direction attract each other, and for two parallel conductors carrying currents in opposite directions repel each other. Since the current in the two wires flow in the opposite direction, then the two wires repel each other. We need to find the equilibrium height H, right? Will the wire CD rise? Let Fi, right? Let Fi be the magnetic force between the two wires. Then the wire CD rises until the upward force Fi due to the current's balance is the downward force of gravity. Therefore, we can write force due to current minus weight is equal to 0. The magnitude of the force per unit length between the two wires carrying currents of I and I prime is given by, so force due to current divided by length is equal to mu naught times I prime times I divided by 2 pi r, and so Fi, force due to current I, is equal to mu naught times I prime times I times L divided by 2 pi r, right? Well, let's call this equation number 1, and now we substitute, now doing substitution in equation number 1, right? We get mu naught times I prime times I times L divided by 2 pi r is equal to mg. Here I prime is equal to I and r is equal to h. Therefore, we have mu naught I square times L divided by 2 pi h is equal to m times g, right? Or here solving for h is equal to mu naught times I square times L divided by 2 pi times mg. This is m. Okay, well, the mass per unit length of the wire CD is lambda, that's equal to m divided by L, and therefore height h is equal to mu naught times I square times mu naught I square divided by 2 pi lambda times g.